Topic 6-7, linear translations. This is the last topic in this Unit 6, and it's kind of going back to a review of linear translations because since we've been looking at what happens with a quadratic change, shifting left and right, up and down, it was a good idea to go ahead and review linear translations. So there's some excellent examples of this transformation in our Holt textbook if you want some more view of that. And Chapter 5, Section 9 on page 3, starting on page 357. And again, you can always go look up linear translations for a more visuals view on mathisfun.com. So I encourage you to go look at that too when you're trying to work through some of these. Okay, let's remember back in section 6-6 that moving from the parent function y equals x squared, again, I'll show it, well, instead of drawing it, I'll just let you look at it on my graph calculator up here. This is y equals x squared, and this is y equals x. So if you recall, let's just do these examples. This is a shift up 5, where this is a shift down 5, but if it's in the parentheses, it moves to the positive numbers, even though it says negative, because your answer would be a positive 2, when this is actually moved to the left as at negative 3, but in the binomial is a positive 3. So let's just recall those things. But if we're looking back at linear graphs, watch what happens if I change from y equals x. Let's go ahead and take this one off. I'll put it there. We're going to just put 2x. So right now we're just dealing with lines, not quadratics. But if I graph that, there's the parent function, and notice what happened with y equals 2x. 2x ended up slanting a lot more than the parent function y equals x. So notice what happens when these are linear. Describe how the graph changes with each equation. If I started with 2x, it's going to be up 2 over 1, up 2 over 1, up 2 over 1. So the only thing, this is my parent function, we can go ahead and write that, y equals x. If it's a positive 5, this shifted to this point here. The negative shifts the line to here. Notice that the slope didn't change at all. That slope stayed the same. It just had a shift from here to here and here to here. Again, this isn't a very visual, and you do need to be reminded that on your graphing calculator, just like a widescreen television, it's going to kind of stretch things. So it appears as if it's not as square, but we'll be talking about shifts of steep and less steep when we look at these. But look at this one. If I put this in parentheses, I'm actually shifting this whole thing to the right 5 places. And this one, it would be shifted to the left 5 places. So let's look at that. If I put in 2 parentheses, x minus 5, close the parentheses, graph that. Notice what happened. It's a parallel graph. They do not cross. It'll always have the exact same slope, but it shifted to the right 5 units when it was a negative. If I'd said positive, it would actually shift over to this negative 5 and make a straight line. Okay, so if I were to give the equation of y equals 3x minus 1 and write the equations as if the equation moved, then what I needed to do is if I wanted to move down 2 units, this is where this comes in, I'm going to just add to that negative 2 to the negative 1 a negative 2. So that becomes the same slope. Notice how the slopes weren't changing. It was just where it ended up falling on the y-axis. Same thing with this one. If you go up 1, I'm adding a 1 to it, then it would actually end up going, this goes away, negative 1, positive 1 is 0. So that would be like saying plus 0. But you don't have to actually put that there. So the only thing that's going to happen here is that it shifts upward. So lots more examples. Let's go through all of these. If it's going to be a left shift, then inside of the parentheses, I kept the 3x minus 1, 3x minus 1, but it was a left shift. So remember, left is toward the negative 2. You'd end up with a line on negative 2, but it has to be a positive shift inside the parentheses. Leave like this so that we can see the shift. Don't actually combine these two together. Like that would actually be a positive one. But let's just show it in vertex form. Alright, so this one, if I want to move it right 4 units, then inside the parentheses has to be a negative 4. Everything else, where the 3 was and the x, that stays the same. Because remember, our original equation was y equals 3x minus 1 from the previous page. It's the shift from that location. Okay, so here's 9 through 14. You're given a whole different equation. First, you're going to want to do what? Rearrange. So if you want to write that, we have to rearrange into y equals mx plus b. So by moving the 3 became negative, the 4 stays there, but then I have to divide out. They're not showing this step, but this is dividing through a negative 1 all the way across. That became a positive 4. This becomes a positive 3x, and this becomes a positive y. Notice what happened when you divide by a negative 1 all the way across, everything changes to its opposite sign. So you're actually looking at this equation here to answer all of the questions here. Alright, so the slope of the line that's parallel to it would also have a 3 as its slope. This is being our slope. What would the slope be if the line was perpendicular? This is just a review from previous units. You're going to take that 3 and flip it, which means takes the opposite reciprocal. It was a positive 3, so it becomes a negative 3. It was a 3, so that's like 3 over 1. So when you flip it, so just make note, you're taking the opposite reciprocal. And reciprocal, fancy name for flip. Just flip the sign. Write an equation that would move up 2 units, so you're just keeping 3x plus 4 and just adding the 2, so it would shift up to a 6. If you move down 5 units, you combine these two constants and it becomes a negative 1. If you want to move it right 4 units, leave it in vertex form, you're actually shifting it toward a negative. It's actually going to be a positive 4, so you have to put the negative 4 here. But notice I kept the 3 and the 4, just like in the original problem here. The 3 and the 4, you've kept this 3 and this 4. It's this inside the parentheses that makes this movement. If it moves to the left, it's a positive inside the parentheses, but again, the 3 and the 4 stay the same. So go try some of the problems in 6-7 in your assignment.